Okay, the clock is 3 o'clock here in Sweden, where I'm located, and 2 o'clock British summertime as we go after in this European Teams user group. I hope you can hear me and probably see me and my presentation. If not, yeah, you will not hear this, but if you don't hear me, say something or write something.
We can hear and see you.
Great, thank you. My name is Linus Cansby, and I work as a consultant based in Sweden. I work mostly with Teams nowadays, but I have a background with Skype for Business and Office Communicator and even live communication server when that was popular way back. I work mostly with voice, and that's why this is one session I want to talk about network and how to prepare your network for voice and video. I write on a blog called link.se. It's an old name, but at least the content is newer. You can find me on Twitter or LinkedIn, or you can, if you want to, you can also send me an email. For you that listened to the session before here with Morten, we run a podcast together called Teamspodden. Probably some of you won't understand what we say because it's in Swedish, but tune in anyway. In this session, I will talk about real-time communication and how to get your network work perfect for voice and video. Back in the days when or even currently when I go out to customers that have problem with Skype for Business, one of the most common problem is that they have some issues with the network. The other common thing is that they had the users are using bad audio devices or uncertified audio devices. But now we will focus on the network. So I will talk some about how Teams traffic works, and it's almost the same for Skype if you're still using that. I will talk about the Microsoft network and how to get into that as quick as possible, and I will show you some tools that you can use for troubleshooting and preparing your network for Teams. What is this real-time communication? It's this communication that is live or almost live without any delay. So it could be voice, like audio or video in a meeting. It could also be desktop sharing. So all these communications rely on a fast delivery of the network package. It could be a peer-to-peer session. So if you have two users talking to each other, that's a peer-to-peer session. Or it can be a meeting like we have here today, a meeting with many participants. Since it's live communication, it is more sensitive for if you have a poor network setup or there is some issues in the network. If you send an email to someone, it doesn't matter if you get that they get that email after 1 minute or 5 minutes, or some of us prefer if we don't get the email at all, because we want to have the traffic in Teams instead and all communication in Teams. But if you have a conversation or a call with someone in Teams and you have a delay of 5 seconds, that's really much, or even 1 second in a audio call can be very annoying. Imagine that your network is a road and the bandwidth is the lanes. So the more lanes a road have, the more cars can drive there. But there could be a pothole or maybe a car that stopped somewhere in a lane, or other congestions that make it hard to drive on that road. The option is not to build more lanes on that road. You have to see what the problem is and maybe fix that pothole. It's the same in the network. There you have the bandwidth. So maybe you have a 100 megabit connection to internet, but you still get warnings that in a Teams call that, oh, there is a problem with this network connection and you should fix it. The solution is probably not to get more bandwidth and upgrade to 200 megabits. There is probably something else we have to check first. You can also have different intersection when you're out driving. So this can make your trip longer. For each intersection, you have to decide where to go. And if you say that you are a big gang out driving and you're driving in different cars, maybe someone gets lost on the way. It's the same in the network, but here is the interconnections, or here are intersections here. It could be a firewall or a gateway or switch that the traffic have to pass by. For each of these intersections, you will add one hop, and the more hops you have, the more places where your packets can be lost. One example that we see sometimes is that the company we go to have a proxy server installation, and that can cause a lot of problem for both Skype and Teams traffic. So if you use proxies, try to not use them. Get rid of them or whitelist the Teams traffic. Even if the manufacturer of the proxy service say they support Teams, you should not use the proxy and bypass it for Teams traffic. When you are driving with your car, you may be going to visit somebody that lives long away. And it doesn't matter how many lanes there are on the road, it will still take a while to get there. And it's the same with voice traffic in a network. So even if you have the perfect network, the voice traffic still have to travel a long distance. And for a network, we use fiber cables that use the speed of light to transport network packets around the world. And we are limited by this speed of light, so we can't go faster than that. So when you're planning your network, you still have to consider the distance between the users and the server. So maybe you have a user placed in Australia joining a meeting in Europe. That distance might be making some latency, and the latency you will notice in a call when you have two people talking to each other and they talk at the same time. So one person starts to say something and then the other one say something at the same time. So you get two people talking over each other, and that we don't want. We also notice when you're switching from old telephone lines to Skype or Teams in locations far away, the latency is still the same, but since the quality is much better in Teams or in Skype, you could have the same latency, but the quality is so good that the users expect that you have no latency, because what they hear is perfect quality. So that could, if you can't build away the latency, you have to educate your users. Then we also have another problem with all the audio traffic is delivered in small packets. So when you order something online, maybe from online shop, and maybe you order something from IKEA, it will be delivered in multiple small packages, and then you have to assemble them. It's the same in the network. The audio use or the video traffic is chopped up in small packets, and when it's received, the other side, you have to put it together again. And if you have any problems on the way, one or many of these packets can be lost. That's what we call package drop. So that we don't need either or want. I often get like, what should we look for? How much bandwidth do we need? So there are some figures that you should try to hit. So for example, for an audio call in Teams, you need about 30 kilobits. Or for a high definition video call in peer-to-peer, you need about 1.5 megabit. And we have some requirements for latency that should be below 100 milliseconds. You can see, if you want to read more about this, you can go to this URL, bit.ly/teamsnet, and you will see all the figures. We often talk about two different types of media flows. We have the peer-to-peer calls. It's a call between two people. So two users call each other and talk. Then the media flow will be directly between these two people or their endpoints, if it's possible. It could also be escalated to a meeting. So that's the second type of media flow. We have meetings. It could be a call that's escalated from a peer-to-peer call, or it could be a scheduled meeting, or maybe that you're using the new Meet Now feature that was rolled out a while ago here. And with the meetings, all the media flow will go to the servers instead of between two clients. And when you use a meeting, Teams will try to connect with something called high ports. If those are closed outbound, it will try to connect to a transport relay on UDP ports. I will show you here in next slide how that works. To say that we have two people called Adam and Chris that are going to organize a worldwide or a Oktoberfest, in this case, a nice summit about Teams. In this case, they sit inside their corporate firewall and are going to talk to each other. So Adam, his Teams client, will check with service in Office 365 with the signaling. This signal is check if Chris is available, and sends out a signal to his clients that, hey, Adam tries to call you. And Chris' client will reply back, okay, I'm here. You can reach me on this IP address. And Adam's client will try to connect directly with the media flow. If they are not inside the same network, we can use something called a relay. The same signaling, we go out to Office 365 or Teams services to check if Chris is available and online and where he's available. Maybe he's on his mobile phone or on his PC at home. And Adam's client, since they are not on the same network, it will not be able to connect directly. So the peer-to-peer traffic will be blocked. So instead, it will go up to this transport relay server that will relay the media traffic between those two clients. These transport relay servers are placed around the world in the Microsoft data centers. So and your Teams client will go to the closest one based on the IP address you come from. And we have the third example here of the flow. So if we have a meeting, we still have some signaling on port TCP 443, but here the traffic will go to Teams services, to the Teams conference service in Office 365. And for Adam, in this example, he's able to connect on high ports. But for Chris, that's not able to do that. He have to go to this transport relay server and then off to the Teams conference service. So Microsoft have enabled us to connect to conference service and to other clients on different paths in your network. So if the first path is blocked, it will try the next one and next one, and until the clients are able to connect to each other or to a relay server. Teams will try to use UDP instead of TCP. And that's because TCP is a protocol that sends more, it talks more before it sends the packet to the receiver. It will ask the receiver, are you ready to receive this packet? And they will reply, yeah, I'm ready. Okay, I will send the packet. Okay, send the packet. And we'll talk back and forward before sending the packet. And the sender will not send the next packet until the first packet is delivered. So we get a lot of overhead with TCP, and when we're using real-time communication, we want it to go very fast. So then we use UDP instead. And UDP is more of a send and forget. UDP doesn't care if the receiver gets the packet. And in real-time communication, that's better, because we have some mechanism to repair. So even if one packet is lost or a few packets are lost, we can repair the audio. And it's better to lose a small part of a conversation than you get a delay just to wait for the package to arrive. But if you are sitting behind a firewall that is blocking Teams, blocking UDP, for example, you sit on an internet cafe or a cafe, and they have blocked, they have just opened TCP port 80 and 443. Then we will be able to do a fallback to TCP, but we don't prefer that, and we actually don't want to do that. So I will not show it today, but there is some tools you can use in Teams and Skype where you can see what networks are using TCP more than UDP, and then you can go into investigate those networks, why they are using TCP instead of UDP. One easiest way to remember the different ways of talking for TCP and UDP are those two jokes. There you can see that TCP is more talkative, and the UDP doesn't really care if the other one gets the joke or not. So if we check the anatomy of a media session, when you talk into the microphone here, that will be an audio wave. That audio wave will be chopped up in small pieces. These pieces is a couple of milliseconds each. They will be sent into a packet, and that packet is going to be delivered over to the receiver. Perfect. Here all packets are delivered to the other part, and they get the same audio wave, and will be able to listen to that conversation. But if we have some problem, then Teams will use something called forward error correction. So in this case, it will combine two packets. So the packet 1 will be sent into one package together with the 2, and the 2 packet for audio piece number 2 will be sent into this combined packet, and number 3 into, so we get some redundancy of the packets. And then it's sent over to the other part. It will be a slight overhead, but not that much, so it matters. But if we lose some package, so these two packets, 3 and 4, and 4 and 5, with those combination, it's lost. As you see here, the packet, or when it's received here, we're losing a small part here. And that's maybe not that good. But then we have the audio healer, the code that Teams uses, that can heal this and figure out what are we losing here, or what are we missing. And maybe you're being a Teams or Skype call where you hear that someone gets a bit of robotic voice. That's the audio healer that goes in. I often hear the recommendation when I talk to IT partners that they recommend their users not to use Wi-Fi. You should always use the network cable when you have a Teams meeting or Teams call. I agree that the network cable is better. You will get better network performance with a cable than some Wi-Fi connection. But today, when you buy a new computer, you probably don't have a network card or a network port in a laptop.
Linus, something happened with your audio quality.
Oh. Okay, I hope you can hear me now. So
Much better.
Yeah, great. I switched from Plantronics to Jabra device here instead. I'm not sure what's happened with my device. So, Wi-Fi connections. I hear that many IT departments recommend that they use that their users shouldn't use Wi-Fi, that they should use the network cable instead. But when you buy a computer today, you probably don't have a network port in that computer. So it could be hard for users that they have to bring a dongle or a adapter, network adapter, and connect to the USB port. And so I said that we should prepare your Wi-Fi network for real-time communication. And there are some easy steps to do that. One thing in a office environment could be that you install more access points. You can also implement quality of service. So all the audio and video traffic sent from the Teams client are tagged with the quality of service tags. And these can be used by the Wi-Fi equipment to prioritize traffic. Some Wi-Fi access points have a feature that buffers packets. So when you go to a web page, it can buffer a couple of packets and then it sends it away. That's not good with real-time communication. So here you have to configure the access point for real-time communications. Also, one problem we've seen when we've done network assessments out at customer sites is that the drivers they have on their laptops, so the Wi-Fi drivers, could be a couple of years old. And newer drivers is probably better. They can have bug fixes and maybe some new features. So only by updating the drivers, we have some customers that had got a better Wi-Fi experience for Teams traffic. Meetings. You probably heard that the meetings will be hosted in a data center close to the first user that joins. This is good to know when you design your network, because if you have US users and you have a European tenant, they can use the meeting services in a Teams or in a Office 365 data center in US instead of connecting to the tenant in Europe. So one example, if a German user schedules a call or schedules a meeting, and there is one US user in that meeting, and they join the meeting first, then the meeting will be hosted in a meeting service in a data center in USA. This shouldn't matter that much, but if you are a lot of European users in this meeting and only one US user, then it could be good if you as an organizer join the meeting early and have the meeting hosted in European servers. And it could also be a good meeting policy that you always join your own meetings early, so you can prepare it. Yes, you might have seen before. This is an overview of Microsoft's large network that they have around the world. They have not only their own fiber cables and cables around the world, they also have some data centers and edge sites where you can connect. They are connected to different peering points around the world. And these peering points is a place where service providers like Microsoft and internet service providers meet and connect their cables. Microsoft say that their network is one of the top 2 around the world. I would say that's marketing language for saying that they are number 2, so their network is the second biggest. And so when you are designing your network, you should try to get into this Microsoft network as soon as possible. I have an example of a customer with different sites around the world. And they only had one internet access. So a user in South America had to connect over to the firewall in Europe, and then from here out to internet. And when they were connecting to Teams, they had from internet to Microsoft network. So not the optimal route, especially not if they were going to host a meeting. Then with a local internet breakout, they could be able to use the data center in North or South America. So instead, to set up this with a lot of local internet breakouts. So the user in South America could instead connect to a local firewall and out to the internet. So there they minimize the path that users or their Teams traffic had to travel on their internal network, and they could hit Microsoft network sooner. Live events is also something we had to consider when talking about the network. Live events is a feature in Teams that you can use to broadcast meetings up to 10,000 viewers or more. This will use Azure Media Service, and it will use TCP and not UDP in this case. But one problem is that one stream of this is, in average, 1.2 megabits. So if you have a lot of users in the internal network watching the same stream, it could really eat up all your bandwidth. And for that, we have 3 different third-party services that you can install and to optimize this stream delivery. What it will do is you will send out the live events to Azure Media Service, and then you will install a small agent on all your computers within the network. Most of these services can also use WebRTC if you don't have the agent installed. And when you send out the stream from live events, it will create one or a few streams to a couple of clients, and then these clients will create a peer-to-peer network. So instead of maybe having 100 or 200 streams through your firewall, you will have one or a few, and then within your network, inside the network, the clients will create a peer-to-peer network and share this stream. Another feature is that you will also get some extra statistics with these tools. So this is an example from Hive, and after you have your live event, you can get some see, for example, where your users or where your viewers were located, and you can see the quality of experience that they had. You can see how long they were watching your broadcast or your live events, and you can also dig into these reports and see how much bandwidth they had to use and how much they optimized their viewing experience with using this Hive or one of the other content delivery or enterprise content delivery network tools. What you also can do is, if you are going to have a town hall meeting that you're going to broadcast to all your users, you can create a silent test. So a week before you're going to have the big broadcast, you can use this silent test and send out network data to all your clients. The end users won't notice anything, but then you will get some statistics back, and maybe you can see if you had a problem site, and then you can start see why was it a problem with this silent test on that site. So let's check some tools that you can use. These peering points I talked about, it's where Microsoft meet up with different internet service providers. So if you can check this database and see if your internet service provider is located in a peering database or in a peering point close to Microsoft or the same as Microsoft. If they're not, you can discuss it with them. If they're not willing to change, you could go into this database and see if it's possible to find another ISP that you can use. So you can easily search for a location and go into one of these peering points and see what internet service providers are located here. If you go to this address here, you will get directly to all the peering points that the Microsoft are connected to. Another tool you can use is traceroute. So here you can see how many hops you have until you reach the Teams network. So the first one here is the local router, then you will see your corporate network and your ISP hops, and then you will come into Microsoft network. So it's these first hops you want to minimize. And then it will come into Microsoft network, and here it will be optimized for audio traffic. And then you will reach the transport relay. We also have this tool called Network Testing Companion, where you can start a test. And this one will first test the connectivity to all Teams servers. And here we got an error, and afterwards it will automatically test the quality. And we can view the result here. So if we want to, we can click here where we got some network connectivity problems. We could click on the report button and we will see some details in a text file. And here we can see that when I tested this, I had problems connected to some of the servers that Microsoft use. Then you can use this file and see where the problem is. So a small summary: optimize the network path from the endpoint to Team services. Use a local internet breakout. You can connect to Microsoft network as soon as possible, and check the connection to Microsoft from your internet service provider. And the last step is kidnap a network engineer. And with that, I would say that keep them in the Teams project. So when you start discussing implementing Teams, have someone from the network team in the project. Thanks for that.